Hi there, I'm Hao. This is just another video of me solving random number problem. So today we have isomorphic string. So given two string S and T, determine if they are isomorphic. Um, Isomorphic means that if the characters in the S can be replaced to get T, all occurrence of a character must be replaced with another character while preserving the order of the characters. No two characters may map to the same character, but a character may map to itself. Okay, so if we have like egg, right, and add here, right, we can know that E is mapping to G. Oh, sorry, E is mapping to A, right, and your G is mapping to D here, right. So that is valid, right. Here also valid, right, because P is mapping to T, right. We're checking each letter by letter. A is mapped to I, right, and we see the P again, and the P should map to T, right. Then the third letter is T, so it's valid. E is mapped to L, and then R is mapped to E. So in the second example, it is not valid because we have F uh, mapping to B, right? But O is mapping to A, right? But we have O here, and it is mapping to a different character. It's not valid, right? So the mapping had to be two ways, right? Yeah, the mapping has to be two ways. So as we iterate to the index, right? Because we know that the length of the two strings will always be equal to each other, right? So we can have an S map here, right, and a T map. So if the if the current letter is not yet in the map, we're gonna add that to the map, right? And we map it to the current index in the T, which is A, right? And we also do the same thing, right, for the T map. So if A is not yet in the map, we add A, right, and we map it to E, right? So on and so forth, right? Let's look at the second example here so we can see how we when I return false. So we're mapping F to B, right, and B to F, and then we move on to the next index, which is I. Index value, we're looking at O and A. Right? O is not yet in the map, so we add O and A, right, and then A and O. And lastly, we are looking at the last characters here, because O is already in the hash map, right, the S map, and it is mapping to A. But if we look at the index, right, of T, it is R, so we can just return false here. So if we iterate through the whole string and everything looks good, we can just return true. Okay, so let's pull this up. We're gonna have S map and then T not, right? So for let I equal to 0, less than or get long. We can pick either one, doesn't matter. S and T, if they are the same length. So if the S map, right, of SI, so if the current character in S is already in the map, right, and if it is already in the map, right, so S map of the current letter will supposed to be the letter in the T, right? If that is not equal to TFI, then we can return false. And we're gonna do the same thing for T. So we have T map. We have T map, right? So uh, so we're looking at character. So if the character recurring characters have the string t, right? It's in the map, and the mapping of that character, right, would be supposed to be the s character. So if that is not equal to recurring character at s, we can just go ahead and return false, right? And otherwise, we're just gonna set the mapping, right? S map, so s of I equal to t of I, and then t map, t of I equal to uh, s of I, and we can return to idea if everything can map to each other. Okay, so accept it, and it worked. The space, sorry, the time complexity here would be of n, right? Because we go through the string in one pass, and the space complexity would be of 1 because we only have ASCII characters, right? And that is a finite number of characters, and that is never grow with the index, right? So the mapping will not exceed the total number of ASCII characters. So the space is constant. Okay, so let's submit. Yeah, and yeah, thank you for watching.